Good day, grade 12s. In this video, I will be working through some series and sequence questions based on the June 2022 exam paper that you guys wrote in the second term. Now, when it comes to sequences and series, remember we have three main sequences, which is arithmetic, geometric, and quadratic. Arithmetic has a constant first difference, and geometric has a constant ratio, and quadratic has a constant second difference. And the difference between a sequence and series is, in a sequence we have a list of ordered numbers, okay, and in a series we are adding all of those numbers or terms together. Now, just as a quick just as a tidbit of information, in your number or your question paper, number patterns will account for approximately 25 of your marks. Meaning, if you have those 25 marks along with the algebra questions, you can already have at least 33% for your paper. So if you know things like calculus and so are not your strong suit, focus on your algebra and number patterns to allow you to build some marks there. If we start working on the question paper that you had, the first question that you had in regards to this was question 2.1, and it says, given the geometric sequence 9/2, 9, 18, and then there's a few numbers missing, and then finally 2304, determine the value of R, the common ratio. Now, what's important to note here in this case, if they give you a sequence in this manner, where we have some numbers missing and then finally we have a number at the end, this would be the last number in your sequence. So they're actually already giving you quite a bit of information here. And our question 2.1.1 asks, determine the value of R, the common ratio. Now, when it comes to a geometric sequence, we know that all the terms are just so all the different terms are just some multiple of one another. Meaning, to get from 9/2 to 9, we needed to multiply with 2. Then to get from 9 to 18, we need to multiply with 2 again. So the constant ratio in this case would have been 2. But now, not all of us can see this immediately. So if we want to calculate the common ratio, we can take term 1 and divide it by term 2 and divide it by term 1. So this is going to be 9/9/2, which we can rewrite as 9 divided by 9/2. And then by our laws of multiplying with fractions, or our rules, the division becomes a multiplication and the fraction flips around, and then we will find that our answer is just 2. So R in this case would just be 2. Now the next question that we have then asks you, okay, how many terms are in this sequence? Now, as a bit of reminder, we know that your R value is going to be 2, and the last term in this case, if you remember back, is going to be 2804. So the sequence that you were given is 9/2, 9, 18, and then finally 2804. This is my last term, so the 2804 is my last term. My R value is 2, and my A value is always term 1, so that is going to be 9/2. Now, to determine the number of terms that are on the sequence, we are going to use the Tn equals to A times R to the power of n minus 1 formula, because we know the term value and now we want the term position. We want the value of n. So it's going to be 2804 is equal to 9/2 times 2 to the power of n minus 1. We simply substitute in all the values we have. Now we need to start to solve this. Now remember, in this case we have an unknown in the exponent, so we want to try and get this 2 to the power of n minus 1 separated from everything else and get everything else to the other side of the equation. So we are going to start by getting rid of the 9 over 2, and we do that by multiplying with 2 over 9 on both sides. And then we're left with 512 equals to 2 to the power of n minus 1. Now remember, when we have unknown in the exponents, we have two ways to solve it. Either using logarithms or to make the bases the same on both sides of the equation. In this case, it is entirely possible to rewrite 512 as 2 to the power of 9, which is then equal to 2 to the power of n minus 1. So therefore now, since the bases are the same, we can equal the exponents. So 9 equals to n minus 1, therefore n is equal to 10. So there are 10 terms in this sequence. Thus, there are 10 terms in this sequence. Okay. So now our next question is now taking things a little bit in another direction, because now we're going to start working with series. Now the reason I say that we're going to be working with series is because remember that whenever you see a sigma, you are just adding things together. So in this case, the sigma, apologies for that, ladies and gents, the sigma notation in this case tells us we're going to start adding from term 1 up until term infinity of the sequence 6m to the power of k minus 1, and that gave us 12. Now they want us to determine the value of m. So first of all, remember that this part of your sigma notation, that is your Tn for the sequence that's being used to form the series. Now in this case, you can see that it already represents a r to the power of n minus 1 sequence, meaning geometric, and it makes sense because we're adding to infinity. So, and the only sequence or series that can add up to infinity are geometric series. So we know that this needs to be geometric. And if we take a look at the 6m to the power of k minus 1, it already resembles a times r to the power of n minus 1. So from this, we know that our a value needs to be 6, our r value is simply just m, and from the information given, we know that the sum to infinity is going to be 12. So from there, we can now simply just use our formula that says the sum to infinity is going to be equal to a over 1 minus r, and now we can substitute in the values we have. The sum to infinity is 12, our a value is 6, and our r value is just going to be m. Now we need to solve for m, and we do that by multiplying on both sides with 1 minus m. So if we multiply on both sides with 1 minus m, we are left with 12 times 1 minus m equals to 6. From there we can multiply the 12 in, so we have 12 minus 12m equals to 6, and from there it is a simple linear algebraic equation. So we start by isolating like terms on the different sides of the equation. So it's going to be minus 12m equals to 6 minus 12, which is then minus 12m equals to minus 6. We divide on both sides with minus 12m. So we're left with m equals to minus 6 divided by minus 12, which would just give us m is equal to a half. So at this point, the analysis and your deducing of information from the question is what would have been important in this case. Now, for the next question, we then have the following information. The third term of a geometric series is 18 and the fifth term is 162. Determine the sum of the first 7 terms where r is smaller than 0. Now in this case, it comes down, we again need to determine some information, and from the fact that we have for a geometric series we know, or sequence, we know that the term value is always equal to a times r to the power of n minus 1. Now if we continue to build and work on this, then we know that for term 3, t3 would be equal to 18, which is equal to a times r. N in this case would be 3 minus 1, which would just give us 2 at the end of the day. For term 5, we know that it's just going to be 162 is equal to a times r to the power of 7. No, not 7, sorry. It's going to be 4. Now from there we have 2 equations, 2 variables, so meaning we are going to have to tackle this using simultaneous equations, or a form thereof. Now for geometric series, if you need to solve for a or r and you are at this point in time, there's a cheat you can use where you take the equation with the higher exponent of r and divide it by the equation of the lower exponent of r. So in this case we can take equation number 2 divided by number 1. So it's going to be 162 divided by 18 is equal to ar to the power of 4 divided by ar squared. And from there we can simply simplify, and we're going to have 162 divided by 18, that becomes 9, and on this side with the ar's we are just going to be left with r squared. Now to find the value of r, we just take the square root on both sides. So r is going to be plus minus 3, because the square root of 9 is going to be plus minus 3. And now it's important to go back to the information, because they told us that r must always be smaller than 0. Thus the r value we are going to use is r is equal to minus 3. From there we can then simply find our a value by substituting r equals to minus 3 into either equation 1 or 2. So I'm going to take r equals minus 3 into equation number 1. So 18 is then equal to a times minus 3 squared. So it's going to give me 18 is equal to a times 9. And then to get rid of the 9, so from there we divide on both sides with 9, and we have that a is simply equal to 2. So up until this point we've been able to calculate that r is minus 3 and a is equal to 2. But this does not answer our question yet, because they asked us to determine the sum of the first 7 terms where r is smaller than 0. So meaning from there we now need to find the sum. So we are going to use Sn equals to, and this is a geometric series, so we use a times r to the power of n minus 1 divided by r minus 1. And we know that we want the sum of the first 7 terms. So a is going to be 2, r is going to be minus 3, and n is going to be 7 minus 1 over minus 3 minus 1, and we take our calculators. And we find that this will be equal to 1094. And then finally we get to the last question from question 2, and in this case they tell you that the general term of a quadratic number pattern is Tn equals an squared plus bn plus c, and its first term is 8. So first important thing that they note here is that term 1 is equal to 8. Then they tell us that the general term of the first differences of the pattern is tk equals 4k minus 2. Now what they mean by that is, say for instance we have the quadratic number pattern. So we have term 1, term 2, term 3, term 4 from the quadratic number pattern. Then to find the differences, or the differences between term 1 and term 2, the formula to determine them can be tk equals to 4k minus 2. And since it will be the first one, t will be 1, or k will be 1. So essentially all that this tk equals 4k minus 2 means is that this is the formula we can use to determine the differences between the terms of the quadratic. So that's all that means at the end of the day. So they then ask us in 2.4.1, determine the next two terms of the quadratic number pattern Tn. So they've already started by giving us term 1, which is 8, and then from the rest of the information we know that the difference between term 1 and term 2 will be the first tk. So it will be the first small t term. So we can say, okay, we need to find out what t1 is, and that will be 4 times 1 minus 2, which is 2. Therefore term 2 is equal to 8 plus 2, which gives us 10. As a reminder again, this small t1 is for this, it's the we get that from the tk equals 4k minus 2, because it's the differences between the terms. Then for term 3 we need to know what small t3 is, which would be 4 times 2 minus 2. So it's going to be 8 minus 2, which is equal to 6. Therefore term 3 will just be equal to 10 plus 6, which would give me 16. So the terms that you would needed to know is then term 2 is equal to 10 and term 3 is equal to 16. The next question then asks you, okay, show that the general term of the quadratic number pattern is given by Tn equals 2n squared minus 4n plus 10. So remember, now you know what your quadratic sequence looks like. It's 8, 10, 16, and we know that since it's a quadratic, there's going to be two differences, or we're not going to have a first constant difference, but we're going to have a second constant difference. So 10 minus 8 gives me 2, and 16 minus 6 gives me 6, and then this difference will be constant, which is 4. Now to determine the value for a in the general formula, which is an squared plus bn plus c, we always use the following formula: 2a equals to d2. So the second difference. So in the general formula for a quadratic, which is Tn equals an squared plus bn plus c, we always use this formula to determine the value of a. So 2a is then going to be equal to the 4, because that is my second difference. So it's going to be 4. So therefore a is 2. Then to determine b, we always use the formula 3a equals to 3a plus b is equal to d1. Therefore, we know that a is 2, so 3 times 2 plus b, and this d1 is going to be this difference over here. It's always this first difference. So 2, therefore we have 6 plus b is equal to 2, and b will then be minus 4. Then finally for c, we can say a plus b plus c is equal to term 1. We always use this formula to determine c in this case, and then it's going to be, we know what a is, which is 2, b is minus 4, and then c is just c because we're trying to calculate it, and the value of term 1 in this case is 8. So if we do some simplification first, then we have minus 2 plus c equals to 8. The minus 2 goes over, and then we have c should be 10. Therefore, the general formula for this quadratic number pattern is 2n squared minus 4n plus 10. Okay, and that was your 3 marks. Now with the last question in this case, they ask you, which term of the quadratic number pattern will be equal to 3050? So they're asking you which term, so they're asking you what value of n, and they're telling you that the term value is 3050, so they're giving you Tn. Now in the previous question we just showed that Tn equals to 2n squared minus 4n plus 10, and now we can just substitute 3050 into the position of Tn. So 3050 is equal to 2n squared minus 4n plus 10, and now we have we again have a quadratic pattern in this case. So we start by throwing over the 3050, or not a quadratic pattern, a quadratic equation. So we are going to try to get everything on one side of the equation to equate it to 0, so we can use factorization or the quadratic formula. So we just throw the 3050 over, so we have 2n squared minus 4n plus 10 minus 3050. So 0 is then equal to 2n squared minus 4n minus 3040. And now to make our life a little easier, remember we always try to see if it's possible to simplify, and in this case we can divide with 2. So then 0 is equal to n squared minus 2n minus 1520. Now this is going to be impossible to try and factorize. Well, not impossible, but it's going to take a lot of time. So our easiest way to continue from here is to use the quadratic formula. So minus b plus minus b squared minus 4ac over 2a, and in this case, instead of equaling the x to this, we are equaling our n value. Now in this case our b value is going to be minus 2, so we have minus 2 plus minus the square root of minus 2 squared minus 4 times 1 times minus 1520 divide by 2 times 1, and if we simplify this we get 2 plus minus the square root of 6084 over 2, and from there we can then split it up in our two sections. So n is equal to 2 plus the square root of 6084 over 2, or n is equal to 2 minus the square root of 6084 divided by 2. Now if we finish this for the positive part, 2 plus square root of 6084 divided by 2 it gives me that n is 40, and for this bottom one it gives me that n is minus 38. Now since we're working with term numbers, our term numbers are never negative, so the n equals to 40 will be our answer, and we can say the negative 38 will be not applicable. And then that was it for question number 2. Now on that regard, remember, as mathematicians, our tenacity should know no bounds.